This is the literacy video for Victoria Moore and Chris Shaw. Victoria is a middle school science teacher, and I'll be teaching high school chemistry, so we decided to split the difference and look at a science-based text for the 8th and 9th grade levels for physical science. The overview of our lesson will be a reading selected by Randall Munroe from his book called What If? We'll have a setup and prediction of a demonstration, and also the students will write about their prediction and observations. All right, the content and literacy standards that we're working towards are the Next Generation Science Standards, MS Physical Science 3.5, that asks students to be able to construct, use, and present arguments to support the claim that when kinetic energy of an object changes, energy is transferred to or from the object. The Common Core literacy standards that we're trying to fulfill fall under RST 6-8.6, analyze an author's purpose in providing an explanation, describing a procedure, and discussing an experiment in a text. The text is from XKCD webcomic author Randall Munroe. If you've perhaps seen these in different science and math contexts, they're rather humorous, at least in my opinion. He wrote a book that is very interesting a few years ago called What If?, where he answers crazy questions with mostly sound science. Other good chapters to look at from this book include Relativistic Baseball, which examines what would happen if you threw a baseball pitch at 0.9 times the speed of light, what would happen if you had a mole of moles, and what would happen if you somehow made a fire pole to the moon. If you haven't seen it, you should definitely check it out. I bet your library has a copy. The text that we're going to look at for this assignment is called the Machine Gun Jetpack. It looks at the transfer of kinetic energy and momentum from an automatic rifle based on a crazy question by some guy named Rob B. Well, this text originally came from a book. They also have an online link to it that the students can link to so that they can find this as well as many of the other chapters shown. This can be printed out quite easily and used in the class for the students to read through and mark up if they want to. It's a rather humorous read, even if you're not too interested in science. There are a lot of funny comments here that might make it definitely worth your time it takes to read about it and view it. What we'd like the students to concentrate on as they read and analyze this text is to underline the portions of the text that relate to the concepts of physical science, particularly relating force, motion, momentum, and kinetic energy. As the students go through the text, they should be able to distinguish the offhanded remarks, the details about things unrelated to the physics at hand, but be able to key in on the specific physics that we're trying to relate to with the class content. Specifically, we're looking to relate the text to Newton's second and third laws of motion. After reading through the text, the class would then have set up before them a fun little demonstration that's common in physics classrooms that sets up two blocks and two pendulums that have identical weight. The difference between the two pendulums is that one is bouncy and one hits more with a thud that doesn't bounce back. The question that we pose to the students is, which one of these is more likely to knock over the block? Based on the reading that features momentum transfer of machine guns and relating that to jetpacks should help them also understand and make a correct prediction here, but the most important thing is for them to be able to put the prediction into their own words and describe why they think which one will be the one to knock down the block. And here we'd like the students to actually write down their prediction first off so that they can't change it depending on what they actually see. And the second is to be good at kind of a practice run of writing down their logic that they'll refine as they move on towards seeing the actual demonstration. After we do the actual demonstration, and I won't spoil it for you by telling you which one gets knocked down, the students will then discuss what they predicted, what they saw, what the differences were between their prediction and their observation. And finally, what we'd like the students to do for an assignment is to relate to us what their prediction was, if it was accurate or inaccurate, what they didn't take into account, and finally we'd like them to describe why the block that fell down was in fact the one that fell down. So I thank you for watching this. I hope you enjoyed it, and I hope you have a good rest of your summer.